So, one of the other interesting things that come out of modern physics is ideas. We've talked about a few things, but the idea of the double slit experiment when dealing with matter. So, the idea of the double slit, if you remember, we can fire a wave through here and the wave interferes with itself. Excuse me. But we noticed the exact same phenomenon was happening when we were firing matter through that system. So what we end up with is we end up with this idea that particles traveling through this system have to have wave-like properties. And what that wave-like property was, we were going to explore. We had people that were working on it going, yeah, what's this wave-like property? Well, the person that we credit for determining the wave nature of this phenomenon is Deboiglie. Now, Deboiglie to me looked like Deboiglie that I took Deboiglie when I was in college, but it's Deboiglie. Okay, so Deboiglie understands that when light's going, or when matter is traveling through here, it has a wave nature, and that wave nature is proportional to its, well, it's related to its momentum. Okay, so as particles are traveling through here, we find out that the wave that that particle is experiencing is equal to h over p. Okay, so how big that wavelength is, how big is that particle vibrating, is dependent on, once again, Planck's constant, which is this number that constantly shows up when dealing with atomic particles. And there's an interesting discussion about Planck's constant, but we're not getting into it. Divided by the momentum of the particle. Okay, so that's how we were able to, that's how we believed the wave-like property was. And it turned out that that idea holds true for the double slit experiment. Okay, so when particles go through here, we believe that because of their wave nature, that they're allowed to travel through both ways and interfere with themselves, with itself. One particle, one wave, like a standing wave going through here, talking about diffraction, generating these generating these wave fronts, generating points of constructive and destructive interference. Well, that's Deboiglie. That's what Deboiglie discovers. Okay? He says, well, that wavelength that's going through there is dependent on Planck's constant and the momentum of the particle.